Yo, what's up everybody? This is Philip and welcome to another video on my channel. Today we're talking about Lakehouses. Now you probably heard about Lakehouses and they have the potential to replace the data warehouse in our analytics platform altogether by adding data management capabilities on top of a data lake. So today we're talking about what are the challenges of the existing approaches and how Lakehouses are trying to overcome them. Now let's waste no time and let's get started. Now the first question to ask is, what is the existing standard architecture of data analytics platforms? And the existing approach, or the most commonly used existing approach, is a two-tier architecture comprised of a data warehouse and a data lake. Now, the data warehouse we need for BI and reporting use cases because they require highly structured data and SQL access. And that's what the data warehouse is good for. On the other hand, we have the data lake, which is required by advanced analytics use cases like machine learning, AI, and these things, because these frameworks that we use, they are already based on file access and they require large-scale data exports. And that's what a data lake is good for. So it makes a lot of sense to have two systems, right? So why should we bother? That leads us to the question, what are the challenges of the existing approach? To keep it short, we are facing three major challenges with this approach, which you may have experienced yourself. These are data staleness, complexity, and costs. All of them resulting from the fact that we have employed two systems. Now, not only do we have to develop, maintain, and operate two systems, but also the data flows between them. We have to develop two sets of ETL processes, each of which being a potential source of errors. What makes things worse is that we have employed two different systems, leading to varieties in SQL dialects, data types, and schemas. And finally, despite all of the drawbacks, we don't even have an optimal system for our advanced analytics use cases because we don't have data management capabilities in our data lake. So no built-in versioning, indexing, or ACID transactions for these kinds of use cases. All right, so how can we overcome these challenges? So advanced analytics requires direct file access and data management capabilities. Therefore, the only way to overcome this particular challenge is to add data management capabilities on a data lake. If we had data management capabilities on a data lake in turn, we could actually consider to remove the data warehouse altogether from our analytics platform, eliminating all the other limitations which were the result of having two systems in place. And this, my friends, is the central question for the development of Lakehouses. Is it possible to design a system on top of a data lake using open file formats, which provides the data management capabilities that we are already used to from a data warehouse? All right, and now the most important question. How do Lakehouses approach this question? Now, the idea is very simple. We limit our system to only a data lake, which has no computing resources. We store metadata in open file format directly into the data lake. And all client applications have to implement a set of protocols to access data in the data lake. In a sense, all clients have to obey the rules which, if they are implemented correctly, add data management capabilities on top of the data lake. All implementations using this approach are called a lakehouse. And at the moment, there are two major implementations which are commonly used, which is Delta Lake by Databricks and Apache Iceberg. By using this approach, we are basically eliminating all of the drawbacks of the two-tier architecture. All right, my friends, time's up. I hope you enjoyed this video and you gained an understanding what a lakehouse is and why we need it. If you'd like to see more content like this, hit the subscribe button. Thanks for tuning in. Until next time. Bye-bye.